This topic is about shading graphs to identify regions that satisfy linear and quadratic inequalities. The first note to make is how you sketch. So you have two different cases, when y is greater than f of x or when y is less than f of x. In these two cases, because you're not including f of x, it's not equal to f of x, you can't include points on the curve or the line. So you have to draw it as a dashed line. So this becomes a dashed curve when it's greater than or it's less than. If it's a straight line graph, then you draw the line with dashed line. If y is greater than or equal to f of x, or y is less than or equal to f of x, then in both these cases, because you're including it being equal, then you're including points on the curve, so you draw it as a solid curve. Same thing as a line. With the line, you have to do a solid line when it's greater than equal to or less than equal to. Okay, let's apply these to some examples. Okay, so sketch and shade the regions that satisfy these inequalities. So the first one, we've got 2y plus x is less than 14. So 2y plus x is less than 14. We know that's a linear inequality. So let's rearrange to get it in the form y equals mx plus c. So we can sketch this. So 2y must be less than 14, take away x. If we divide by 2, y must be less than 14 divided by 2, which is 7, take away half x. Okay, we want it in the correct form, mx plus c, so it's minus a half x plus 7. So if I were to sketch this, it's going through positive 7, here, this line. It's a negative half gradient. Because it's a strict inequality, it needs to be drawn as a dashed line. This point here, we know is 14, because minus half times 14 will give you negative 7. Negative 7 plus 7 is 0. Okay, now we need to decide which part is y is less than half. Is it the bottom half of the line or the top half of the line? So for this thing, what we need to do is always substitute the point 0, 0, so the origin, because it's clearly on one side. So substitute 0, 0 into the inequality. So substitute 0, 0 into 2y plus x is less than 14. So you get 2 times 0 plus 0 is less than 14. Now on the left-hand side, you get 0. Is 0 less than 14? Is that statement true? Yes, it is. That means it's the side, you want the side that contains the origin, which means you want this side. So this side is in your region. Okay, let's look at the quadratic inequality now. So we've got y is greater than or equal to x squared, take away 3x, take away 4. Now it's greater than or equal to, which means it's going to be a solid line when you draw it. Let's factorize it to find the roots. X take away 4, x plus 1 gives us the minus 4 at the end. The middle terms are minus 4x plus x, which gives you negative 3x. So you know the roots of this are positive 4, so 4, negative 1, it must go through negative 4 somewhere here. It's a solid quadratic, solid line, solid curve, because it's greater than or equal to, so it's going to look something like that. Now again, if you want to find out which part you want, the inner part or the outer part of the quadratic curve, again substitute 0, 0 into the inequality. Substitute 0, 0 into y greater than or equal to x squared, take away 3x, take away 4. So you get 0 is greater than or equal to 0 squared minus 3 times 0, take away 4. 0 is greater than or equal to -4. Is that true? Yes, it is. So it's the part that contains the origin. That's the part that you want. So this part is the part that you want. Now, as you can see from the blue arrows and the red arrows, the part that you do want, let's highlight it in yellow, is this part. So that's the shaded region that you want. Okay, let's look at another example. So this one's got 3 inequalities. It says sketch and shade the region that satisfies the inequalities. First one is y is greater than x minus 3 squared, which is obviously a quadratic. So quadratic with repeated root at x equals 3. And we know the y-intercept will be, if you expand this, you get a constant term at the end of 9. So it will be 0, 9. So if I sketch this out, so x equals 3. Nine would be here. Now it's a strict inequality, so it's going to be a dashed line. 3 is a curve. Okay, again, we need to find out which part we need, the inner part or the outer part. So let's again use 0, 0. Substitute 0, 0 into y is greater than x minus 3 squared. So you get 0 is greater than 0 minus 3 squared. Is 0 greater than 9? Nope. So it's the part that doesn't include the origin. So we want this part. Okay, let's look at the second example. Second inequality. So we've got y plus x is greater than or equal to 5, which implies y is greater than or equal to negative x plus 5. Okay, again, it says it's a greater than or equal to, so it's going to be a solid line. So 5 is here. It'll also go through 5 here. Solid line, like so. Now you want to identify which part you want, the top half or the bottom half. So you substitute, again, the origin. Into the inequality. Is 0 plus 0 greater than or equal to 5? Is that statement true? Nope. Which means you want this, you don't want the origin. The origin's not in the region, so it must be this part. Let's look at the last inequality. Y is less than x minus 1. Okay, that's already in the form that we want it. So it goes through minus 1. It's a positive gradient, positive 1 gradient. And it's a dashed line because it's less than. That point must be 1, because 1 taken 1 is 0. Now again, I need to identify which part I want. Substitute 0, 0 in. So 0 is less than 0, take away 1. Is 0 less than minus 1? Again, that is false. So I don't want the part with origin, so which means I want this part. Now you can see, if you look at your arrows, you want everything above this line and below this line, so it ends up being this part that we want. So that's the region that satisfies all these three inequalities. Okay, the last one is going the opposite direction, which means you're given the graphs and you're trying to find out what the inequalities are. So the sketch shows the graphs, the curves with the equations y is equal to 2 minus 5x minus x squared. So obviously the curve is that one, because that must be the quadratic. So that must be y is equal to 2 minus 5x minus x squared. Okay, now I know 0, 0. I want everything inside the quadratic graph because it's the yellow part that I'm looking at. So I know 0, 0 is inside this region. So substitute 0, 0 into y is equal to 2 minus 5x minus x squared. So I get 0 is equal to 2 minus 5 times 0 minus 0 squared, which ends up getting 0 is equal to 2. Now, obviously 0 is not equal to 2. 0 must be less than 2. Now, we're not going to include the equal sign because it's a dashed line. So remember, it's a dashed line, dashed curve. Therefore, it's either going to be less than or greater than, but we've just worked out it's less than. So that means the equation must be y is less than 2 minus 5x minus x squared. So that's the first one, the curved one. Okay, if I use a different color for the red line. So the next one is, let's look at 2x plus y is equal to 0. 2x plus y is equal to 0 is the red line. As you know, y is equal to negative 2x going to the origin. So it goes to the origin, so it must be the red line. Again, because it's a solid line, it's either going to be less than equal to or greater than equal to. Now I need to find a point clearly in the region. So let's look, this point, for example, is clearly inside the region. Let's substitute that point in instead of 0, 0, because if you look at 0, 0, it's on the line. So let's not use 0, 0. Let's use 4, negative 1, 4. So substitute negative 1, 4 into 2x plus y is equal to 0. So what you end up getting is 2 times minus 1 plus 4 is equal to 0. Obviously, it's not going to be equal to 0, but let's just work out what it is. Minus 2 plus 4, 2 is equal to 0. It's obviously not equal to 0. It's greater than or equal to, remember, because this solid line must be greater than or equal to 0. So which implies that our equation must be 2x plus y is greater than or equal to 0. So that's the red one. The last one that I need to do is a blue line, which is obviously x plus y is equal to 4. Blue line, because y is equal to 4, take away x. It's going to the y-intercept. It does have a y-intercept of 4, and it's got a negative gradient, so it must be that one. Again, it's a solid line. Therefore, it must be less than equal to or greater than equal to. Okay, again, let's substitute that clear point, my negative 1, 4. So substitute negative 1, 4 into x plus y is equal to 4, which is the original equation that was given. So is minus 1 plus 4 equal to 4? Obviously it's not. So it's 3 is equal to 4. Obviously it's not equal to 3. Is less than or equal to 4. Therefore my equation must be x plus y is less than or equal to 4. So we just use a point inside the region to help us identify which inequality it is. So it must be less than or equal to. So those are my 3 inequalities that represent that shaded region in the sketch.